Assalamu alaikum everyone. This video is being recorded for our DLD theory project, and we three are going to be presenting you our fast finger circuit implementation. I am Hashir Khan Niazi 2023430. With me my group mates are
Muhammad Umar Farooq 2023536
and
Mustafa West 2023564.
okay. So our implementation is based on D flip-flops and basic other logic gates, and we also plan on implementing counters in our circuit. As you'll see in the following video, we'll be demonstrating each of those components of our project.
Thank you. Thank you. Now I, Umar, will take forward the presentation and tell you about the block diagram, hardware component specifications, and run the Proteus simulation and show you how the project actually works. So, if I am to enumerate the specific requirements that the project aims, that is that we need two AND ICs, we need two 4013 D flip-flops, we need 10 resistors of variable resistances, and we need 4 LEDs and a buzzer and a BJT transistor. So the block diagram is in front of you. This is the AND IC. This is also the AND IC. This is the 4013, the D flip-flop, and this is also the D flip-flop. So the first input of the AND gates of this IC are getting input from the button that the players are going to press, as you can see, and the others are command at a place and they are coming from the other AND IC. I'll show you what is the purpose of this, and it is basically used to lock the input of the other users who haven't pressed the button quickly. So let me just go over to the Proteus simulation. Okay, this is the Proteus simulation. Let me run. Now you see, when I press this one, this is representing the first player. As I press the 1, this LED turns on, this one. Now even if I press anything else, see, I have pressed everything, nothing will turn on. Why? Because you see, when there is no input, let me just reset. When there is no input, we have a 0 and 0 over here. So there is no set by which Q is 0. So this will turn off. And this is Q naught. So this will be 1 because Q is 0, right? So this will go in this 1. This will also give an output of 1. And ending 1 and 1 will give a 1. So this will go in this one. Again, this will repeat, and these all will give 1. But the thing that is stopping the AND gate output to be 1 is the input from the user. This is the user. So as long as no one has pressed the button, this will stay 0. So once I press this button, a signal goes 1, and when 1 and 1 come at the AND gate, they both give an output of 1, and that is used to set the D flip-flop. Now what this does is it sets the Q to 1, which then turns on the LED, and Q naught becomes 0. Now this 0 will go in this and of course this will become 0. This will give the output 0, which will go in this, and both of these outputs will become 0, which then will go in all of the other ANDs. So even if the user is pressing these buttons, you cannot get an output of 1. So that's the locking condition. For the reset, let me just show you. I think there is some error. Okay, so for the reset we have these two, the 10 and 4 of the IC, of the dual IC we are using. So we have command them at a place. Over here also we have command them, and then it is going to a common button. So when we press this, it gives a one signal to this, and this is reset button. So that resets all the simulation. That's it from my side. Thank you.
The basic principle of this circuit is that whoever presses the button first his value shall be stored, while the rest of the value shall be discarded. As we can see over here, I am pressing this button first. This LED has switched on. I am pressing the other buttons like this. Their inputs are discarded. When I reset it, I can again